Let us take an example about continuity. Study the continuity at x is equal to 1. If the function is discontinuous, then classify it. What about this function? And as you can see, it's a piecewise function. Of course, the question didn't say graph it, but I will graph it to make it easier for you to understand. But of course, if you can do it without doing the graphing part, does not matter. In my case, let me show you both. Over here, studying the continuity, meaning that I need the conditions. First one, f of 1. Where should I substitute to find f of 1? Is it in the first or the second equation? Of course, in the first. Excellent. Why is that? Because there's an equal. So I will find the answer as 1. Now, approaches from the right. Should I substitute in the second or the first or the second? Right, which is greater than 1. Excellent. So I will substitute in the second equation and find the answer. If left, I will substitute in the first equation and find the answer. And as you can see, they are not equal. So once we said does not exist, what do you think? This is continuous, this is not continuous, and it's removable or infinite or jump? Excellent, it's a jump because the second condition for the limit is not equal. Okay, what about if you didn't understand it using only numbers? What about if you need a graph to understand this? No problem. Use the graph, be my guest. Over here, what I did a table, and as you can see, I substituted with number less than 1, but I started the function, the table, as you can see, by 1. Substitution, and I got these answers. Over here, I started from 1 and above. Then the next step, I did the substitution, and I did the graphing. Do you think by looking at the graph, from the graph, if I want to find f of 1, the answer is what? Perfect, it's a 1. If I want to study the limit from the right, the answer is what? Look at it from the right. The answer is a 2. Yes, this one is 2. Sorry for that. If I want to study it from the left, the answer is what? It's a 1. Same answers like we got. So it does not exist. From the graph, can you tell it's a jump? Yes, we can tell. If it's f of x as x minus 1 absolute, or x is not equal to 1. What does that mean, x is equal to 1? And another thing, 3fx is equal to 1. If I don't want to study that graphically, I want to do it only algebraically. So f of 1, the condition. f of 1, when the x is 1, the y it's a 3. Perfect. Now, approaches from left and approaches from right and approaches from left. What is the answer when I substitute over here? It's 1 minus 1, which is a 0, and 1 minus 1, which is a 0, the same thing. So the answer is 0 for the limit. And this are not equal. So basically, its function, this one, is discontinuous. What about doing the graph? To do the graph, I will do the vertex first. This is a 1 and a 0. The next step, that's the vertex. Then I will choose a point. I can do that mentally. I can say that the point over here is what? 0. When I substitute for 0, the answer will be? When I substitute for 0, the answer will be a 1. So this one over here, it's a 1 and a 0. Okay, no problem. So it's a V shape, opens up, and the vertex for that is 1 and 0. Now, what did you notice? Because not equal, what happens over here when you plot the vertex? You will put an open dot. And what about the 1 and 3, which is given over here? You will put a solid dot. Now again, let us study the condition from the graph. F of 1, it's a 3. Perfect. Approaches from the left, approaches from the right, and approaches from the left. Over here, it's a 0, and over there, it's a 0. So limit as f of x as x approaches a 1, it's a 0. These are equal to each other? Of course not. Now, what do you think the classification is in this case? What do you think? Is it a jump? Is it a removable? Is it an infinite? It's a removable. Well done. Thank you.